Hey folks, today we're going to be covering how not to go out of memory. That's how to train models without your GPU giving you an error saying OOM or out of memory. I'll get started in pretty quickly today, probably in the next minute. Let me know if you have any questions. I'm going to give some really high-level tips on how not to go out of memory, give you my ranked preference for how I would fit into the GPU or GPUs. And then I'm going to go through a script for tuning Unsloth, tuning OSS, GPT-OSS using Unsloth. And there are a few specific challenges with OSS. It's the latest open source model from OpenAI, and it is quite compact and powerful, which makes it pretty attractive as a base if you're going to tune your own model. Probably you're going to strongly consider the 20B model or the 120B model. And if you want to use the larger one, I recommend first you do everything on the smaller one. And then, yeah, that's the TLDR, Rick. You've got it. And so I think I'll get started here. How to avoid going out of memory. I am going to get a GPU up and running in the background. So I'm going to start my GPU template. I'm in the advanced fine-tuning repo, which some of you have purchased access to. So I'll show you some of the contents there. And I'm just going to be building a script. But I'm going to pick the largest GPU, which is going to be one of my tips. Technically, the B200 is larger, but it's not quite as well supported. So I'll usually tune on a H200. And I'm going to tune for long context on OSS 20B. So I'm just going to call it OSS long context. And I'll let that deploy. And this script here, by the way, I do have a video. I'll put it in the description explaining how to set up these one-click templates, but it's going to update the system. It's going to make sure it sets my Git username. So I'm already logged in with Git, and then it's going to clone the repository. And then it's even going to do some installs. Now, I'm not doing any installs here in this template because I'm going to do them in the notebook, but sometimes I'll add in code here that will pre-install everything in the TOML in my root file. This is how we do things for the ARC AGI prize. We install everything from a TOML, and it means once you spin up the container, it's got everything installed and you're ready to go. So I'll put a link in the description about that. So that pod should be up and running. It'll take a while to just get started. Well, not that long. In the meantime, my tips for avoiding out of memory. So first thing I recommend, so imagine you're training a model. It could be OSS. You want to train it. But you're getting an out of memory error. Could be because your context is too long. There are a whole variety of reasons why you might go out of memory. In short, you're using up more of the GPU's VRAM than what it's sized to. So there's a hierarchy that I would look at of things to reduce the memory that you require. And the very first thing in the hierarchy I'll put in is use a larger GPU. Now, I think there's a tendency, I see this a bit online, to try and use the smaller GPUs because they are cheaper. And this is true. If you check here on RunPod or any other service, you can get a much cheaper GPU for 40 cents an hour if it's A40 versus $379 per hour for H200. But I think this is often a false economy for two reasons. First of all, you get a lot more flops on the larger GPUs. But second of all, it's a lot more hassle to use multiple GPUs than to use a single GPU. You just run into a lot more issues. And so I rarely think it's worth trying to force into the cheaper GPUs. You're better off just trying to fit everything onto the single GPU. So that was my first tip. Use a larger GPU, if possible, a H200. I wouldn't go with B200 yet, not supported very well, but probably someday soon I'll be saying maybe go B200. Rick has got a quick comment here. Thanks, Rick. Long sequence. Okay. I'll have to look at exactly how they do the long context, but I am going to talk briefly about long context methods. So first thing is use a larger GPU. Second one, and you'd probably be familiar with this, is instead of full fine tuning, try LoRa. So LoRa, you're just training small adapters instead of training the full weights. The reason why training the full weights is particularly expensive is because every weight also needs optimizer parameters and gradient parameters to be stored. So it's not just the weights, it's the optimizer and gradients. And with LoRa, you've much fewer trainable parameters. So you've much fewer optimizer and gradient parameters that you need to save. So you try LoRa. If you want an intermediate step, You can do LoRa, plus you can train the embeddings. If you look at any of my videos on fine-tuning, not any of them, often I don't train the embeddings. You train the embeddings if you're going to change particularly the use of the chat template. That's when you might want to change the embeddings or introduce new tokens. Training the embeddings will increase significantly the amount of parameters you need to train and the memory you need. So as an intermediate step between full fine-tuning and LoRa, you could consider just LoRa and training the embeddings. Okay, so that's LoRa. Now, some of this sounds standard. It is kind of standard, but I'm going to get to a few other ways to reduce memory. So now you've got LoRa. You're down to that size. You're still running out of memory. What are your options now? So next option, and I may end up rejigging these options, but you're going to reduce your batch size. So if you were training at, say, a batch of 16 or 32, let's say, which might be standard, reduce to, let's say, 4, and use gradient accumulation. So you're going to keep the same virtual batch size. So if your batch size was 32, you're now going to use gradient accumulation of 4, and you're going to use, gradient accumulation of 8 and a batch size of 4. And that would be 8 times 4 is equal to 32. So you're using gradient accumulation. This comes with a small trade-off in quality, because you need to accumulate, and there's some error in accumulating across the steps. It was actually a really big error because of how wrongly some libraries were doing the gradient accumulation, notably transformers and Unsloth, but it was found and it was fixed in large part thanks to Unsloth. So now the error is quite small with turning on gradient accumulation, and I recommend that for reducing the batch size and saving memory. Next, you've reduced the batch size. All right, cheers, Rick. I like it. Once you've got the batch size down and you're still running out of memory, what else can you do? 4, you can reduce the LoRa rank. So typically, LoRa is the size. LoRa rank is the rank of the matrices that you're going to train. You have a big matrix that's maybe 1,000 by 1,000, but for LoRa, you're going to use 2 small adapters that multiply to give a large matrix, but themselves are smaller matrices. And often the rank you choose, so the characteristic dimension, is going to be maybe 32, 8, 64. But sometimes I think we probably set it a bit higher than is needed. So you could just reduce it. So if you have it at 64, try 32 or try 8. Just try reducing it. I think something else I should say is that for larger models, you possibly need a smaller rank. And that's because if you have a larger model, you're going to have more parameters in general. So for the same rank, you're going to end up with more trainable parameters on a larger model. And given the same amount of data, you probably therefore need less LoRa rank because you're anyway going to have more parameters. So generally the intuition is use a smaller LoRa rank for larger models. But what I'm saying here is if you need to reduce memory, you can reduce the LoRa rank. So that is my tip number 4. Sorry, the 2 4s are misleading because they come from different rows. Next tip here. So you've reduced the batch size, you've reduced the LoRa rank. What are you going to do next? Well, you want to make sure you're using an efficient form of attention. So there are a few forms of attention. One of the most basic is eager, which is kind of doing a full attention calculation. It's multiplying the query matrix by the keys and then multiplying by the values matrix. And if you multiply out all of that, you materialize really large matrices, and these take up a ton of memory. And that's why early on we had what's called flash attention. And what flash attention does is it breaks up large matrices, so you don't materialize them all at once within the GPU's internal memory, and you instead split them up into chunks and you compute them through in smaller chunks, and this greatly reduces the VRAM. So if you don't have something like flash attention, you're going to take way more memory, particularly for longer sequences. So this is true particularly for longer sequences. What about compiling the model? Well, compiling, yes. I think if you're talking about inference, compiling as well, compiling often is going to give you speed up. It's going to find ways to run the calculations faster. Whether it gives you big VRAM savings is kind of a different matter. And often compiling is more for inference than for doing training. So I'll go on here. You got to use an efficient form of attention. Now, here's the problem with OSS. Flash attention will support typical architectures like Llama, for example. But it does not support, or OSS does not work with flash attention. OSS does not work. So OSS defaults to eager and uses tons of attention, uses tons of memory. So it's really hard to train OSS on long sequences if you're using transformers or a lot of libraries, because it doesn't work well with flash attention. And by the way, I should say that flash attention, not only are we beyond flash attention 2, which is kind of still somewhat state of the art, there's also flash attention 3, but this only works on Hopper architectures. So this would be H100 and later. And this one here works only on Ampere. So A100 and later, not on T4s in Colab. So you have this problem with OSS because flash attention is not well supported. I think it is actually supported. Well, I did now that I think of it. It's not supported through Unsloth, but I did run it through transformers and I was able to get it to run, but I did find that the loss curves are not quite right. And there are known loss issues in the transformers implementation of OSS, which is actually a separate issue. But let me get to the solution, which is Unsloth have implemented. Well, there's one other thing I should say before this. It's become more common, instead of using flash attention, to use SDPA, which is scaled dot product attention, and it's in the PyTorch library. And this can be as good or better than flash attention 2, as I understand. I'm not an expert on this, but this is now commonly a default. So you'll see SDPA is commonly being used now as a default for attention. It's a lot better than eager attention. And what Unsloth have done, they've basically found a way to make SDPA work for OSS, and it's done using what's called flex attention, which is yet another library. So transformers will just default to eager. If you install flash attention and you're on the right supported GPU, it will run flash attention, albeit there are some loss issues. And Unsloth have kind of solved this. Well, they have solved it because they allow you to run using flex attention, which I think is related to SDPA, and this is going to save you a lot of VRAM, and this is what we're going to look at today in the script. So in general, if you're trying to save on VRAM and don't want to go out of memory, you want to make sure you're using one of these implementations rather than using eager attention, which is going to cause you to run out of memory. Now, other things you can consider, I'm moving down on the list here, and by the way, this probably should be right up at the top of the list. So probably even before you're considering using a larger GPU, you should have the right form of attention, because that's just going to cost you a lot of memory if you've got long context. And last, well, I don't know about last, but now you can consider using 4-bit training. And 4-bit is typically, let me just turn down the music actually a little bit. It can be a little bit annoying. Yeah, okay. Consider using 4-bit training. This often means bits and bytes. NF4. NF4 is a type of 4-bit. It's a data type. And what it does is it will take a bunch of parameters and it will provide quantization points. So let's just say you want to represent numbers between 0 and 2. You could quantize that by doing, well, this would be 5 values, but a 5-value quantization of 0 to 2 would be 0.51, 1.52. But instead of distributing them linearly like that, like I did, you could distribute them normally, which will have more of them towards the center and then just a few on the tail. And this normal distribution of quantization values is NF4. It tends to lead to a bit better data quality. So it's called normal float 4, which is different than int4, which is a linear separation of values, and also different than MXFP4, which is the OSS data type, which is a floating point 4. And the reason why it's MX is because you have a data type that's doing a 4-bit precision, although it's floating point. Floating point means that it's using the bits to represent the exponent rather than to represent the mantissa, which is the front part. But it's MX because there's actually another scaling factor above it that's used for a group of 4 bits. So you've got a group of 4-bit weights and they all have common scaling values. So it's a hierarchical approach, MXFP4, that's used by OSS. But either way, if you're doing 4-bit training, you're probably using bits and bytes if you're going via transformers or Unsloth, and you're going to be using NF4. Typically, I try avoid this if I can. I've recently been training OSS, and I'm just using it because I'm using it mostly because there's a clean way currently to merge NF4, to merge that trained model down and back to MXFP4. So Unsloth, I'll show you this, but Unsloth allows you to merge back down to MXFP4. It will do that by default if you merge and specify MXFP4 and you have loaded a 4-bit model. If you've loaded a 16-bit model, it will merge to 16 bits. So you probably, in theory, can train the 16-bit and find a way to then convert it to MXFP4, but it's probably not as straightforward. So that's why I'm actually training in NF4. But typically, my favorite configuration is to train in BrainFloat 16 and with LoRa. That's my preferred way. And then I try to avoid NF4 quantization. Basically, if you look at the memory that you're trying to use up, you're going to have, let's say this is all my memory here. You're going to have the base model weights. Then you're going to have the trainable parameters, and that's going to be the gradients plus also the optimizer parameters. And this is what's a lot smaller with LoRa. And then you have the activations, which scale with sequence length, and batch size. So if you move to NF4, NF4 is going to reduce this. But really the problem for VRAM in a lot of cases is it's usually your activations are taking up a lot of space, which is going to be helped by flash attention and smaller batch size. And then the other problem is your trainable parameters, which is helped a lot by LoRa. So often, if you look at the full, especially if you're using a bigger GPU, if you're using OSS, the base model, even if you do it in 16 bits, if you train in 16 bits, it's going to be about 40 gigabytes out of 140. So you still have 100 gigabytes that are free for all of this here. Whereas if you train in NF4, then you're going to have less than 10 gigabytes. So you've saved 30, but it's maybe not a huge savings. So you can kind of keep good precision by doing the 16 bits and not really take up that much memory if most of the memory is going towards trainable parameters and activations. Okay, so then where do you go after this? You've got 4-bit training. What are you going to do next? Well, next, if the model fits on a single GPU with batch size 1, and you just want to speed up, then you do DDP, which is distributed data parallel. Now, that's obviously a big caveat because you may not still fit on the one GPU, but if you do and you just want speed up is your issue, then makes sense to do distributed data parallel. If that does not work, then you go to FSDP, which is fully sharded data parallel. And this is going to split the tensors vertically, so they're across all the GPUs. A lot more complicated, but you can fit a model that's too big for one GPU. So that would kind of be my decision-making tree. There's a point here, cut entropy. Yeah, cut cross entropy loss is used to reduce VRAM by Unsloth. Yes, this Unsloth in general reduces VRAM versus transformers. So that's probably a point to make as well. Unsloth generally reduces memory usage versus transformers. So yeah, I would recommend probably using Unsloth. DDP will work with Unsloth. FSDP will not work. Well, I could say will not work easily, but I think will not work with Unsloth yet. I don't know. So you'll have to run transformers. And by the way, by going to transformers, you get a 2x slowdown. So FSDP will only make sense if you have at least 3x GPUs, because you're getting a 2x slowdown going back to transformers. So you have to go back to at least 3 GPUs in order for the maths to work out to be favorable. So I should write that there as well. Let's just put it in the other tips. Going from Unsloth to transformers is a 2x slowdown. So you need 3x GPUs to justify doing FSDP. Okay. So that's why DDP is nice if you can do it. There's a video I made on DDP. I'm not saying it's totally straightforward, but it's doable with Unsloth, and you do get a linear speed up. So if you multiply on 8 GPUs, you will get 8 times faster training. So that's good. So yeah, this is kind of a winning formula here. FSDP, tough. It's tough. It's very doable on transformers. I have another video on that you can check. It's in the fine-tuning playlist. So it's doable, but yeah, you need to remember you're going to slow down just from moving away from Unsloth. All right, Mert. I learned DLOCO, distributed low resource training. Yeah, so that's very fully sharded. I'm not sure if how the model is sharded. I need to read more about it. Whether it's used for really big models or smaller ones. Okay, so that's my high level. Start with the right attention, use a larger GPU, do LoRa, reduce the batch size as low as possible, reduce the LoRa rank as low as possible, consider using 4-bit training, and then start considering DDP or FSDP. And maybe I've forgotten some things, but that's kind of a quick summary of what you might want to do. So we're going to now train OSS on some long sequences, and hopefully my pod is started up. So pod looks ready to use. I'll go into Jupyter Lab, and my repo should have cloned. So if I open up here, interesting, Mert saying more here on DLOCO. Each island has model replicas training their own. Okay, so each island needs to fit the full VRAM requirements, fulfill the full VRAM requirements. So I'm working in advanced fine tuning. You can learn more at trellis.com. And I have quickly put together a script that is called Unsloth long context. And if you're not in a position to, or you don't want to buy access to this script, you can always go to Unsloth, to the GitHub repo, and you can go down and check out this 20B script here for fine-tuning OSS 20B or 120B. I will make a few quick comments on this, and you can adjust the script from here. So yeah, there's a few things I want to say quickly about loading these models. I think, yeah, there's a few things I want to say. It's not obvious what these things do. If you load Unsloth OSS 20B, it is going to download the MXFP4 format. This format is not trainable yet. I don't know if it will be. I think it might be at some point. So what happens is it will download it, and I'm not sure if it requantizes it on the fly or if it actually just downloads the bits and bytes version, but you will only be able to train this model here if you set load in 4-bit to true. And it will then train it not in MXFP4, but in bits and bytes 4-bit, which is the NF4 format. If you load this model here with dash BF16 in caps, it is going to load a 16-bit version of the model. That one you will be able to train, you will be able to fully fine-tune, you will be able to LoRa fine-tune without quantization. So you'll be able to turn this to false here, and you could turn this to true. So that's what the BF16 does. And yeah, these are just ready-made 4-bit ones that are requantized from MXFP4 to bits and bytes 4-bit. So just a reminder, if you run this and you try to fine-tune it without turning on quantization, it's not going to work because it's going to try backprop with MXFP4, which is currently not supported. So yeah, if you want to tune in 16-bit, load with the BF15. If you want to tune with 4-bit base, turn on true and just load this one here. Okay, so I'm going to do that. Let me just check up here upstairs to see about the installs. If you're using OSS, you do need to update Unsloth to the latest dev version. I'm not quite sure. Maybe it's been pushed to PyPy, but I don't think it was. So you need to make sure you push that. Right here, I'm installing on the system. If I set up an environment in the root of my repo and had a toml there with the install packages, I would not put system because I would want to install it into the Jupyter kernel, but I haven't actually got, well, actually I could set up a Jupyter kernel here and install it in there. But for now, I'm just going to install it on the system. It would be better for environment management if I more carefully use the kernel. But for now, I'm installing on the system. Okay. These are just some checks I had. So now we're going to download the model. So we'll download Unsloth, the MXFP4 version, but we're going to load it in NF4. Now, there's no modules named Unsloth. So I'm just going to restart the kernel. And let's see if that works. No module named Unsloth. Let me refresh. Click here to reinstall. That looks like it's installed. Move down. Hopefully I have better luck this time. Why do I have no model named Unsloth? So what I can do is go back up here, put in a plus uv pip show Unsloth, and see. Yeah, uv is not installed on the system. So I need to do pip install uv. So that's a problem. You can't use UV if you don't have UV installed. And that hopefully should now work for installing Unsloth. UV is a lot faster than pip. I noticed that Unsloth are using it themselves now. So makes sense. It's just a lot faster. So that is going to take a second to install. Probably I need to restart the kernel, would be recommended. Or I could try and power through and just download the model. Once I download the model, I'm going to apply some LoRa adapters. This is where I said you could apply a small LoRa adapter. This is relatively small, a LoRa rank of 8. You know, I like using OSS LoRa. Okay, so let's see. I like using rescaled LoRa. Yeah, so Unsloth is currently installed. So I'm just going to restart the kernel. Rescale LoRa will adjust the learning rate based on the rank. Smaller rank means faster learning, so you're in a lower dimensional space, you can move faster. And hopefully this time, Unsloth is finally going to load. Okay, great. So Unsloth is loading. We'll apply the adapters. And we can run a quick model generation. Unsloth have this nice setup for the chat template, which is a bit different for OSS. Unsloth allow you, they define their own chat template, I think, and then allow you to pass in a reasoning effort, which can be low, medium, or high. I'll add that if you put in complex questions to OSS 20B and to a lesser degree 120B, it will often give garbage responses. I think, yeah, it will. Even 50% of the cases. I know when I pass in hard arc challenges, it gives back poor quality responses. So just be aware of that. And probably it means you need to tune in quite a few applications if it's complex. So I mean, let's just run a quick inference here. It should start to stream out an answer. And you can also check the VRAM. This is a video about VRAM. So we should see the model loaded here. It doesn't look loaded. Is it loading according to our scripts? And looks loaded according to the scripts. Sometimes the runpad dashboard can be a bit slower to show. And it is a bit odd that it's not showing there. Let's see if it's actually reasoning. The adapters look applied, so that's good. But a bit odd that this isn't printing. I'm going to just stop. And let's see if it helps if I do this. It may not help. I may need to restart the kernel and restart again. Yeah, okay. So you can see we're printing out here. We've got the response, and it stops because the max tokens are currently set to a fairly low value of 64. And what we're interested in, yeah, this is kind of annoying. If you refresh the page, it'll allow you to then keep working. So this is actually a bug I've seen recently. If somebody has a fix, let me know. It's pretty annoying if you have to refresh the page every time you want to move down. So what I want to do is I want to train some long context reasoning traces, which means I need to load some data. And the data I'm going to load here is an ARC AGI2 reasoning data set that Lewis and I have prepared. I'm going to check that it's public. And I think it is. No, that's not the data set. It's this one here. And yeah, it's pretty much a task, a reasoning trace, which could be quite long, up as far as 55,000 characters, not tokens, about 20K tokens. A code response. This is a code that will transform the inputs to the outputs. And we've got then the correct, we've got the predicted output of the code and the predicted test output. This is actually not just one output, but all the train outputs. And then we've got the model that generated this trace, which was GPT-OSS 120B. So the reason I'm using this is because I want to show you some long context. So we're going to load that data set. We're going to set the input column as reasoning and the output column as code. Now, this doesn't really make sense if you're going to train. I'm not properly setting up this at all. The way that you want to pass in reasoning, if you really were training for reasoning, is not to just get a long string and double it to make the context long, which is what I've done here, because I'm just trying to make a long piece of reasoning. You would want to inject the reasoning here. And I'm actually not sure for OSS. Let me quickly see how let me see how I inject the reasoning. There are some models that will actually take a separate field. So they will take in a reasoning field like this here, or thinking. I think Quen takes in a thinking field like this, and then you put the thinking here. OSS, I'm not actually sure if that's how you put in the reasoning. We can check in the model here to see how it puts it in. If I remember right, I think Unsloth just used the chat template. So we can see reasoning language, convo. Yeah, so if we look at the convo, I think that convo is pre-formatted. So if we look at that data set that Unsloth are using, we can see the messages. And if we look within the messages, we should be able to see, thanks, Mert, I'm going to check your message there. Yeah, you can see there is actually the opportunity to put in some thinking here. So I'll go down to another one. Role, yeah, there's no thinking for the user, but then when you get to the assistant, you can put in a thinking feed here. So yeah, the correct way to do it actually is to put in thinking here. And by the way, you would not put it into the user, you would put it into the assistant. So you put it in here, and then you put in the thinking trace here. Now, so this, we're going to train it on garbage. Well, we're going to train it on badly formatted inputs, but the whole point I want to show you is just to put in a long input. So I'm going to put it in twice to make it a bit longer. And then for the output, we're just going to put the program. Mert has a question here. Output column was numbers. Was a tokenized version. Oh, I think you probably saw an output column. These here, maybe. I mean, these are the output grids. These would be the solution grids for ARC. I'm not actually sure if that's what you're asking, but feel free to clarify and I'll re-clarify back. Anyway, the point here is I've got a long input and I want to see if I can make it go out of memory, and then I've got an output here. So I'm loading them up and I'm trying to tokenize here, but I've got tokenize equals false because I'm just templating, and I'm trying to create a text column that has the untokenized but correctly templated text. And this text field is what's going to get passed to the trainer. And furthermore, I'm going to reduce the data set down, and I'm just going to filter out things that are actually between 30 and 35K tokens. Yeah, I mean, I was just interested in testing if I could train to that length. So here, it's going to download the data. It'll take the long, well, it'll filter out the ones that are 30 to 35. We'll see how many of those there are. I think there'll actually be only a few, but we only need minimum of 1 because we're going to train out a batch size of 1. You can see I ran earlier and it was only 2 data points. So maybe it'll still be 2. And yeah, it looks like it's still 2. So we have 2 data points. And now we're going to train the model. So we're going to pass it in. We're going to do the trick, well, not trick, but the setting of low batch size, gradient accumulation. If I wanted a virtual size of 32, I would set that to 32. And other than that, if you are training with a text field, the SFT trainer will automatically detect that text field, the text field I've generated here. We can actually print it out. This is the templated prompt. You can see it's got the reasoning system message, and then it's got my user prompt. It's got a user request. And yeah, I've basically put the I put the response into the user field just because I wanted to make a really long prompt. Of course, it would be long if I put it into the reasoning field too, so that wasn't necessarily a good idea. And then you can see in the user field, we've got the assistant response, which starts and just gives the program here, making up the rest. So this is the fully templated prompt. And so we're ready to train. Let's go back and check RunPod. Yeah, okay, this makes sense. So if we've loaded the model, but we haven't yet started the training, it's taking up about 13 gigabytes. That's because it's in NF4. And then we're going to train. So we've set up the trainer. You can decide you only want to train on the responses. So you want to focus the loss only on the response portion, which here would be the code. So we could try that. You do need to set correctly the response portion. So notice how the response here, it starts after start assistant message. So you need to grab this delineator here and use that to set the response part. And so now we have input IDs, which should be everything. But when we run the next cell, which should just be everything that's not masked, you can see what's happening here is we're masking everything that's part of the input, and only these tokens here will have the loss. Only the loss computed on these tokens is going to be used for backprop. So we're focusing the loss on these output tokens. Check the GPU status. Should be okay. It looks like we've reserved 19 gigabytes now, so it's actually reserved even a little bit more. Now we're going to train. So take a moment to start up. But if you try and run this and you don't upgrade to the latest version of Unsloth, you will find that it takes way more memory because it's going to default to just eager. Actually, I should have said when we loaded the model up here, you can see it says flash attention is false, which is true, which makes sense because we haven't installed it. Xformers is not being used. That's correct because Unsloth is using SDPA. And that's pretty much it. There's nothing else to say really here, but it should be using the low VRAM form of attention. If it's not, then we're going to run out of memory quite soon. So let's see if we do. It's going to take a moment, and we should see the memory start to go up. I'm just training batch size 1, 30K length. I'm probably going to see it. I'm going to somewhere around here, 50 to 70%, I'd say. Yes, trying to do them. Right now, I'm just working a lot on ARC, like nearly every hour of the day. And that means I'm spending less time on videos. So I'm trying to at least do a live stream to cover some content. Okay. It's going to take a moment. We're getting to the end, though, of this stream, by the way. I do have to drop off in 5 minutes. And let me know if you have any quick questions before we wrap up. It's either going to crash, which would be embarrassing, or it's going to start training. And looks like it's so far going to start training. There's one more thing I forgot, which is very important, and it's a quirk. But if you pass a validation set, Unsloth will currently default back to eager for attention, and it's going to crash. And I couldn't figure it out. I couldn't figure out why I kept running out of memory, but it was because I was passing a validation set, and that currently is not using flex attention. I believe it will change. I don't know why it is the way it is, because technically it's just a forward pass, like the normal training forward pass. But yeah, that's going to cause issues. So don't pass a validation data set to your trainer. It's actually not enough just to set do eval to false. So you'll see here in the trainer, well, it won't be in this trainer because we don't have a validation data set. Let me scroll down. Sorry, it's a bit of a nightmare because I've got too much printed, too many print statements. So in the trainer here, if you're running with eval, you need to turn do eval equals true. And you also need to pass in a validation data set. So I think it's eval data set, and then you need to pass in the eval data set. Usually you would do it something like this, but you would need to create it up first up top. But be careful, just setting do eval to false is actually not enough. It will still take up all the memory and crash if you set that to false. You also need to set the eval strategy to none. So you need to set that to none, or just don't pass a validation data set. That will make sure you don't run validation and crash it. By the way, if you're using transformers and Unsloth, they use a different variable name here. One uses evaluation strategy, the other uses eval strategy, which is incompatible, but can cause issues. Yes, will it run on Kaggle with 2 T4s? So let's start with 1 T4. You can see here we're using 43 gigabytes with batch size 1 and context length of 32K and LoRa of 8. So that will not fit on 2 T4s because a T4 is 15. So 15 times 2 is 30. So that will not fit. But if you're only training 4K, batch size 1 probably will fit. Probably will even fit on 1 T4. So flash attention not supported. I think that the flex attention, I'm not entirely sure. I think I did a quick run in collab with a T4. Definitely you can't get to 30K, but you probably could do some sort of sequences. So yeah, this is pretty much it. I'm going to just save this notebook. You know, the loss is going down. It's kind of funny because we're giving it the reasoning, so it doesn't make a lot of sense, but everything is working here in terms of showing you how to not run out of memory. I'm going to save this notebook for those of you who have the advanced fine-tuning. If you don't or aren't in a position to get it, take a look at the Unsloth original notebook on the Unsloth GitHub here. And I'll put down below in the description some of the videos, fully sharded data parallel, distributed data parallel, if you want to learn a little more about those fine-tunings. And I'll hope to see you next week. If it's on, I'll try to post a link by sometime early morning, Friday, Irish time. I know that's a bit last minute. I'll try post it a bit earlier this time. And cheers everyone for joining. Appreciate it. Any plans to do more on the RL side? I did quite a bit early this year. I don't know if you've seen the videos on GRPO and SFT. Yeah, I mean, I'm thinking there's a chance I'll probably do one video on RL at some point. Really, the way I see it is it's all about data prep. And I think online RL, oh, that's my alarm saying I need to finish. Online RL, I think, is challenging because when you're trying to generate data and RL kind of simultaneously, you end up just having a lot of low quality data. So I'm kind of a believer in offline RL, where you run lots of inference, you filter your data, and you use that to train, often in SFT, maybe in ORPO, maybe in some kind of GRPO. But I think it's really all about the data. So anyway, I may try, and thanks for the comment. All right, folks, all the best. Cheers.